Hi everyone. In this second video about data mining, I will focus more on the data mining process, machine learning algorithms, and data mining software. Again, you can subscribe to my channel to see a series of videos on data mining and practical examples of using data mining for research or businesses. In the previous video, we have talked about the definition of data mining and its characteristics. Differences between AI, machine learning, and deep learning, and big data. Since data mining is a data-driven method, we need to explore the data to uncover new or unknown patterns that can help us make informed decisions. In order to properly perform data mining, we need to follow a process. Note that on the internet or in textbooks, you might find different steps for data mining. Many of them are based on the author's opinions and experience. Some of them are useful, especially for some specific type of projects. In some cases, we wonder whether such a process has been validated. In this video, I would like to introduce the processes that are actually used by many researchers and practitioners. Despite numerous data mining processes you might find, there are two primary data mining processes that are widely accepted and used in both academia and industry: SEMA and CRISP-DM. The first process is SEMA, which stands for Sample, Explore, Modify, Model, Assess. This process is proposed by SAS Institute, but it has been used in many industries and especially by academic researchers. SEMA is actually integrated in SAS Enterprise Miner software to guide users in conducting data mining. SEMA is a sequence of data mining steps that should be followed to analyze large data and uncover new patterns. In the sample step, we start with data sampling, such as selecting the data set for modeling. The data set should be large enough to contain sufficient information to retrieve, yet small enough to be used efficiently. This phase also deals with data partitioning, which splits the data into subsamples. The training sample is used to train the model, and the validation sample is used to validate the model. In some cases, we can use a test sample to test the final model. In the explore step, we need to explore and understand the data by discovering anticipated and unanticipated relationships between the variables, and also any abnormalities with the help of data visualization. Features such as descriptive statistic, missing value detection, and variable selection can be used in this step. This is rather an important step to understand the variables in the dataset before to start analyzing them. Keep in mind that garbage in, garbage out still applies here. We want to have quality data to be able to produce quality output. The modify step contains methods to select, create, and transform variables in preparation for data modeling. Once you understand the quality and completeness of the data, we can decide specific data treatment, handle missing values and outliers, and perform any data transformation as needed. While data mining can handle noisy data, if you have clean data, we can build valid models. Large datasets tend to be less structured and messy. By reducing noise and outliers in the data and handling missing values, we'll have cleaner and more complete data for analysis. Note that there will be a lot of judgment calls that we have to make in this step, depending on the type data we have and the purpose of the project. In the model step, we focus on applying various modeling or data mining techniques on the prepared variables in order to create models that possibly provide the desired outcome. Machine learning algorithms are used in this step to build models, either for supervised or unsupervised learning. Depending on the purpose of the project, target variables, and the data, we can build multiple models using different algorithms, or we can use a few algorithms but configure them differently to produce more models. I'll have separate videos for each algorithm. The last step is assess, in which the evaluation of the modeling results show the reliability and usefulness of the created models. In order to do that, we need to decide the performance criteria for the models, perform the model comparison, and select the champion model. The champion model will be the best model that will be deployed and used in actual operations. Then another data mining process is CRISP-DM, which stands for Cross-Industry Standard Processing for Data Mining. This process is founded based on the European Strategic Programme on Research Information Technology Initiative, or ESPRIT. It's more popular in the industry than in academia. IBM is the one that has adopted and is using this process. CRISP-DM breaks the process of data mining into 6 major steps: business understanding, data preparation, modeling, evaluation, and deployment. I won't go into the details of those steps because steps like data understanding, data preparation, modeling, and evaluation are very similar to SEMA process. The business understanding step focuses on the business problem that drives data mining. And at the end, deployment step refers to the deployment of the model in real-life practice. Note that the sequence of the steps is not strict. Actually, the process requires moving back and forth between different steps. The arrows in the process diagram indicate the most important and frequent dependencies between phases. The outer circle in the diagram indicates the cyclic nature of data mining itself. The data mining process continues after a solution has been deployed. The lessons learned during the process can trigger new business questions, and subsequent data mining processes will benefit from the experiences of previous ones. As you can see, CRISP-DM is very practical oriented, and that is why it is widely used by practitioners for real-life business problems. From the academic research standpoint, I think SEMA is more suitable, since it focuses more on the process of performing data mining. Having said that, what process works best will depend on the purpose of your data mining project. For my research, I usually use SEMA since there's no actual deployment of the model in my research. Let's move to machine learning algorithms, the core of data mining, data science, and even artificial intelligence. SAS defines machine learning as a method of data analysis that automates analytical model building. It is a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. While machine learning algorithms have been around for a long time, the ability to automatically apply complex mathematical calculations to big data over and over, faster and faster, is a recent development. Examples include self-driving Google car, Tesla Autopilot, online recommendation by Amazon or Netflix, fraud detection, smart assistants like Siri, Alexa, or Google Assistant. Machine learning algorithms can be categorized as supervised learning and unsupervised learning. Supervised learning works best with structured data. It requires a target variable, and models are developed to predict the target variable based on numerous predictors. On the other hand, supervised learning works well with less structured data. It does not have a specific target variable and treats all variables as input variables. Models are developed mainly to detect intrinsic structure of variables. The rule of thumb to decide whether you need supervised or unsupervised learning is to see if you have a target variable and whether the purpose of your research is to predict it. Naturally, there are more supervised learning algorithms compared to unsupervised learning algorithms. Some examples of supervised learning algorithms include regressions and logistic regression, decision tree, random forest, gradient boosting, memory-based reasoning, support vector machine, neural network, and Bayesian network. What algorithm is the best choice for your research will depend on the purpose of study and the scale of the target variable. Methods such as regressions and logistic regressions are based on the same foundation as in regular statistical studies. But in data mining, they are used to analyze much larger data and are subject to less strict assumptions such as normality. It's also worth to note that random forest and gradient boosting are expansions of decision tree, in which a lot of more trees are constructed to find a better predictive model. I have different videos about those algorithms and how to use them. It's a common practice to use multiple algorithms to construct multiple predictive models and compare them to identify the champion model. Examples of unsupervised learning algorithms might include cluster analysis, principal component, or multi-dimensional scaling. These algorithms can be used to group individual cases by similarity or detect underlying factors from data. Again, the foundation behind these algorithms is the same as multivariate statistics, but they will be performed at a larger scale with much larger datasets. In data mining, there are two important approaches that are worthy of mentioning. The first one is ensemble. Ensemble models combine predictions from multiple models to create a single consensus prediction. This is a common practice in data mining, and when individual models disagree with each other, the ensemble model is typically more accurate than individual models composing it. The second one is scoring. Scoring is a process of using a developed model to make a prediction about incidents that yet to happen. Scoring is an important step in data mining to make real prediction using the developed data mining model. The output of the model, the prediction, is called score. Usually, scoring process results in the code of the predictive model, which can be integrated into organization system to produce a prediction of the output. The image shows an example of score code created by SAS. As mentioned, machine learning algorithms are usually constructed and configured by using specialized software. As machine learning continues to grow, data mining software also continues to improve. I will review and compare some top software packages for data mining. These are packages that are widely used in the industry or academia. That means they have been validated and provide robust machine learning algorithms for analysis. There's a long list of software apps that claim to be able to perform data mining or big data analytics. We want to be careful with software created only for the learning purposes. Since while they may be easy to use, they tend to work only for projects at a smaller scale and have minimal algorithms and features. Furthermore, the new software apps in the market also need to be validated as they may have errors in the algorithms in tools. Last but not least, having skills and experience with well-recognized software would add value to your resume in terms of analytic skills, since companies and organizations that you apply for might have already used that software. In this video, I cover 5 major data mining software apps: SAS Enterprise Miner, RapidMiner, SPSS Modeler, R, and Python. These are top data mining software apps in the market. SAS Enterprise Miner and Python are highly recognized in both industry and academia, but they seem to be dominant in the industry. Many organizations currently use SAS and Python for their applications, and analytics employees are usually required to have certificates to prove their skills. SAS has a very large certificate program that is accepted by many companies. On the other hand, RapidMiner, SPSS Modeler, and R are more popular in academia. Instructors and researchers use the apps in classes or research. That's why we see more journal publications using these software apps. One of the most important criteria when we evaluate a software app is the user interface and the level of coding required. For students, instructors, and researchers in the field of math, science, and engineering who have strong foundation and skills in programming languages, coding is not an issue and even preferred. But for the ones in the field of management or social sciences, coding is a major obstacle. From that perspective, SAS Enterprise Miner, Rapid Miner, and SPSS Modeler are the ones with more user-friendly interface and tools. Basically, we can perform data mining with just point and click. But these apps do allow us to integrate codes or write codes to perform data mining if we want. They also allow us to integrate the code with Python to various code libraries and tools. On the other hand, R and Python are programming languages. I don't have to write codes for every step in the data mining process. As mentioned before, if you are new to programming, it will be a steep learning curve and a lot of practice is required to use the software before we can even perform any actual analysis. But if you are good at programming, these apps can provide you with a lot of flexibility and resources in writing the algorithms. The next item is the workspace diagram. Basically, the data mining process involves many steps and many models. So it's not easy to track the steps and models in our analysis. The workspace diagram is a visual tool that allow us to incorporate all steps and models in our analysis by dragging and dropping nodes into the workspace and connect them as appropriate. Steps like importing data files, partitioning, sampling, exploring, transforming data, modeling, and assessing can be done easily with this diagram. I usually build many models using different algorithms or using the same algorithms with different configurations. So I find this tool extremely useful. I can easily make a comparison, track the steps, make the modification, run a path of the diagram, and review the final results. Data mining is an exploratory and iterative process, so it's not possible to get the results on the first try. The diagram makes the work easier to handle. Among those software apps, SAS Enterprise Miner, Rapid Miner, and SPSS Modeler all provide the workspace diagram. On the other hand, R and Python do not have this feature due to the program language nature of these apps. Among the three apps with this feature, I've tried all three and found the diagram by SAS Enterprise Miner is the easiest one to use. I have built many models using SAS Enterprise Miner diagram, including ensemble and scoring, and I have never encountered any confusion or difficulties. Besides, these apps use SEMA steps to present the nodes, which make it easier to find the node you need. SPSS Modeler is okay, but the categories of the node make it hard to find the right one. In addition, the way it handles multiple models and outputs is quite confusing. And if we do not follow the right steps, we will get some vague error messages. Rapid Miner diagram has the same issues, and figuring out how to put multiple models in the diagram is not an easy task. Besides, I found Rapid Miner uses very unusual names for operators in the diagram, which are very confusing to new users. For example, they use a label instead of target variable, example instead of dataset, etc. And in the diagram, they use acronyms of those names, which even makes it harder to follow. As a matter of fact, there's so many unusual operator names that they have to create a glossaries to provide definitions for those names. This is one of the key reasons that I decided to use SAS Enterprise Miner in my course. As for the machine learning algorithms provided by these software apps, I find SAS Enterprise Miner, Rapid Miner, and Python have more robust algorithms, which allow us to perform more complex modeling with more configurations. Regardless, SPS Modeler and R are improving the algorithms, and we start seeing more features in these apps. I just wanted to note that all software apps provide text analytic tools, but I find SAS Text Miner is the most robust one as of now. The algorithm they use in the text parsing, text filtering, text topic, and text cluster are the closest to what we think of text mining rather than just word frequency. Now we get into sensitive topic of pricing. Among these apps, R and Python are fully open source, though, so they are free. RapidMiner is also open source app and is free for academics. It's not free for enterprises though. SPSS Modeler is also not free. It is quite expensive for enterprises. It's still pricey for academics. Finally, SAS Enterprise Miner is also expensive for enterprises. For universities, it is included in the SaaS packages for campuses. So if your university is a SaaS campus, it is free. If not, they have a free cloud-based version called SaaS On Demand for academics. So if price a factor, it is worth considering the free version. Finally, I wanted to summarize some key weaknesses of these apps. As mentioned above, R and Python are programming languages, so there will be a steep learning curve for new users. They both lack the workspace diagram, and visualization is cumbersome with these apps. Both SPSS Modeler and RapidMiner have confusing diagrams, hard to perform model comparison, and confusing nodes and operator names. In both SPSS Modeler and RapidMiner, to view the output graphs, we have to go through some extra steps, especially with SPSS Modeler. SAS Enterprise Miner has an advantage here since all results in table or graph format are presented in the same node. Finally, SAS Enterprise Miner, especially the free cloud-based version, also has weaknesses. The first weakness is the way SAS handles folders and files. Unlike other software such as SPSS and Excel, SAS handles folders through libraries. That means folders containing files must be connected to a library. SAS Enterprise Miner must be connected to the same library to allow us to access the files in that folder. It's certainly cumbersome and requires several steps to open a file, but this is a way SAS always uses to handle folders, as it is easier for managing data for SAS projects, especially when you have many different folders with numerous files. And note that SAS Enterprise Miner is not designed to upload files, change the file name, or move files between folders. Those actions must be done with SAS Studio, which is free. It will take some time to get used to it, but then it will be easier once we understand the process. I have several videos showing how to convert files and work with libraries in SAS. If we use the free cloud-based versions for academics, we'll also be limited to the software speed since it depends on the internet connection and the server performance. Since it is free for all instructors, researchers, and students, there will be a time that many people access the server at the same time, which might cause slow processing time. Furthermore, international students and researchers might face difficulties in accessing shared folders if they log in from other countries. From my experience with SAS Enterprise Miner, it takes the longest to open SAS Enterprise Miner software and open the project. Once that step is done, things tend to go through rather smoothly. Note that the cloud-based SaaS Enterprise Miners has full features at the commercial version for enterprise prices, including high-performance node and text miner. Finally, please note that data mining software is not created for easy data treatment and modification. Software apps like RapidMiner and SAS Enterprise Miner do not even allow us to make changes to the data. The reason is that we're working with a lot of data, and such features might cause some accident changes to the data without us knowing about it. It will be a disaster since the output will be invalid and there is no way for us to find the errors. So do not be surprised if you find out that you are not able to change the data or even variable names in those apps. So how do we make changes that we need? Typically, each software app has features, special features for this purpose. SAS has different tools such as SAS Enterprise Guide. SPSS has SPSS statistics. My recommendation is to clean and treat data in advance using Excel or SPSS before importing the data file to the data mining software. These tools are designed for data cleaning, especially Excel, so it will actually save time. In the next few slides, I will show you the example of diagrams in those apps. As you can see, the diagram in SAS Enterprise Miner is clean and logical. It follows the same process. So it's easy to create multiple models and compare them without getting lost. The node names are quite clear and self-explanatory. RapidMiner also has clear nodes and paths, which allow us to create a large diagram with ease. But the lack of arrowheads could cause confusion regarding the path direction in the diagram. And you can notice acronyms they use for input and output of each node. Most of the time, I found myself checking the glossary to understand the diagram. Finally, the diagram, the SPSS modeler is rather confusing. It is hard to follow the structure, especially when you want to compare the models and review the outputs and graphs. Having said that, there's no perfect data mining software. Each of them has pros and cons. I chose SAS Enterprise Miner for its robustness and ease to use diagram, which is important to my research. I have given some more thoughts to RapidMiner and might create a series of videos for this software later. Please subscribe to my channel to view my other videos and future videos on data mining. Thank you and bye now.